Okay, so we are in part 2 of the Passport to Advanced Mathematics, and we're going to learn our third type of functions, which is quadratic functions, which you will see these on the SAT. Quadratic functions are parabolas, which we'll go over in a second. Before we get into quadratic functions, let's just quickly review the types of functions we know so far. So we have linear functions. Okay, with linear functions, it looks like f of x equals mx plus b. Okay, where m is the slope, is the y-intercept. Okay, the pictures of linear functions look something like this. So if you have an increasing line, m is greater than 0. If you have a decreasing line, m is less than 0. And if you have a horizontal line, m is equal to 0. Okay, in all of these cases, this is the y-intercept, or b. Okay, so that's a review. Then we also have learned exponential functions. Okay, they look like f of x equals ca to the x. Okay, if it's growth, it looks like this. Okay, this point is 0c. You have an asymptote here. Okay, that is a greater than 1. Okay, if it's decay, your picture looks like this. This point again is 0c, asymptote here, and this is a is in between 0 and 1. Okay, so that's just a really quick review. Remember, a is our growth or decay factor, and c is the initial value. This is a really quick review of the two functions that we've learned so far. Okay, so our third function is quadratic. Okay, definition of quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and a does not equal 0. Okay, that just ensures that you have an x squared here. Okay, so basically for quadratic functions, we're looking for an x squared somewhere. Okay, if there's an x squared and it's not in the denominator, and it is the highest power, then you have a quadratic function. Okay, f of x equals ax squared plus bx plus c is called the general form, and the graph of a quadratic function is a parabola. Okay, so quadratic functions either look like this. This would be a parabola facing down, or like this, a parabola facing up, or opening up. Okay, bottom of page 5, it says, are the functions below quadratic? If so, label a, b, and c. Okay, so again, we're looking for an x squared somewhere. Okay, so number 1, it says f of x equals 3x squared plus 8x plus 4. Okay, this is quadratic. You see an x squared here as the highest power. Okay, so a is the number in front of the x squared. That is 3. B is the number in front of the x value, which is 8. And then c is the constant, which is 4. Number 2, g of x equals negative 2x squared minus 4x plus 3. Okay, again, yes, this is quadratic. A would be negative 2. B is negative 4. C is 3. Number 3, h of x equals 0.1 x squared plus 3. Yes, this is quadratic. A is 0.1. B, okay, we don't see a b value, but that's okay. It doesn't say anywhere up here where b can't be 0. So b is 0 here, okay, since there is not a b value, and then c would be 3. Number 4, f of x equals x cubed minus 2x plus 1. Okay, that is not quadratic. It fails here. We have x cubed as the highest power, or 3 is the highest power. Okay, the highest power in quadratic is 2. Okay, so this is no, or not quadratic, because of the x cubed. Okay, on top of page 6, we're going to continue this. Number 5, g of x equals 4x squared plus 3x. Yes, this is quadratic. A would be 4, b is 3, c is 0. We don't have a c value. Again, you can have c as 0. Number 6, h of x equals 3x minus 1. Okay, this is not quadratic. If you said it were quadratic, a would be 0 here since we don't have an x squared. Okay, and looking at the definition, it says a can't be 0. Okay, this is not quadratic. We know what kind of function this is. It is linear. M is 3, b is negative 1, and we could quickly graph that. We would graph 0, negative 1, then we'd go up 3 over 1 to get another point. Okay, number 7, we have f of x equals x squared. This is quadratic. A would be 1, the number in front of the x squared. B is 0, c is 0, since we don't have those. Okay, next example, it says express f of x equals x plus 6 times x minus 4 in general form. Remember, general form is this ax squared plus bx plus c. Okay, so we want to distribute here. So what we're going to do, we're going to multiply the x times the minus 4, and then the 6 times the x times the minus 4. Some of you guys may have learned this as, I believe you call it foiling, first, outer, inner, last. Okay, that's fine to use that. Just make sure you know you can only use that if you're given exactly this form. Okay, if you were given another term, so maybe x plus 6 plus y here in the first set of parentheses, you just want to make sure you take each one and multiply it by each one in the second. So 6 times x times minus 4, and then you would have done the y times x times minus 4. Okay, so x times x is x squared minus 4x plus 6x minus 24. So make sure I did that right. X times times negative 4, 6 times x, and then 6 times negative 4. Okay, this simplifies to x squared plus 2x minus 24. Okay, next example. Express f of x equals negative 2 times x plus 1 squared minus 3 in general form. So again, we want it in this. Okay, so we're going to multiply out. I'm going to do, instead of x plus 1 squared, we're going to write x plus 1 times x plus 1. That's the same thing, minus 3. So let's go ahead and distribute this out first. So minus 2, this would be x times x times 1, 1 times x, 1 times 1. So x squared plus x plus 1 minus 3. So I'm going to simplify inside the parentheses. So this is x squared plus 2x plus 1 minus 3. Okay, order of operations here. Now we're going to do parentheses. So minus 2x squared minus 4x minus 2, and then we have a minus 3. So I'm going to write 2x squared minus 4x minus 5 is the simplified form. Now we have a would be negative 2, b negative 4, c negative 5. Okay, so that should have been a review for you guys. You should have seen this a while ago on how to distribute when you have quadratic equations. Okay, next definition, it says a quadratic function f of x equals ax squared plus bx plus c can also be expressed in standard form, which is a times x minus h squared plus k. Okay, so we've got some new letters here. The a is still the same, that's the number in front of the x squared, but we see an h and a k here. Okay, so below it explains what those are. It says the graph of the quadratic function a times x minus h squared plus k is a parabola with the vertex hk. Okay, so that means the vertex is either the lowest or minimum point or the highest. Okay, so here's your vertex for parabolas. Okay, so if you're given a quadratic function in this form, you can immediately find the vertex. Okay, the parabola opens up, so it would look like this if a is greater than 0, so you would look at the a. It would open down if a is less than 0, so it would look like this. So this would be a greater than 0, this is a less than 0. Okay, this is only if it's given to you in this form. Okay, we're going to learn how to graph this form in a little bit. Okay, but if you're given this form, it's a very simple way of graphing. Okay, which is actually this form up here, what we had. So it says sketch the graph of f of x equals 3 times x minus 2 squared plus 4. Okay, this is given to us in standard form, which I'm just going to write standard form underneath it. A times x minus h squared plus k. Okay, be really careful with this h. It's really common for you guys to see, okay, here's the h and it's negative 2. But notice that it needs to be minus, so h is actually positive 2. So be careful with the h here. Okay, so let's write down what we have. Vertex is hk. So in this case, that would be 2, 4. We also have the a is 3, so it's going to open up. Okay, so our picture is going to look something like that. Alright, so let's go ahead and start graphing this. Okay, so we have 2, 1, 2, 3, 4. This is our vertex. And it's going to open up. Okay, so that's what we have so far. Okay, the only thing left we need to do is find another point. Okay, that'll show us how steep or how shallow our parabola is. Okay, so if maybe another point was here, okay, it's not going to be that steep. But if another point was way up here, it would be steep. Okay, so we just need to find one point, and then it's symmetric across that point, across the vertex. Okay, so I'm just going to come over here and write in another point. Let's just choose x equals 0. Okay, so f of 0. I'm looking here. That's 3 times 0 minus 2 squared plus 4. That's 3 times, this is negative 2 squared, so that's 4 plus 4. So 12 plus 4 is what, 16? Okay, so from that information we have 0, 16. Okay, so this is going to be very steep, which I didn't use enough room. What is 1, 2, 3, 4, 5, 6? Let's go ahead and change this to go up by 2s so we have a better picture. Okay, so we have 2, 4 as our vertex. Then we have 0, 16 as just another point, which you guys can see. And then it's symmetric across that. So it's pretty steep here. Okay, so there is that quadratic function. Okay, on to page 7. Okay, notice we're graphing quadratic functions. We're not getting out our calculator. We're also not using an XY chart. Okay, so to sketch the graph of g of x equals negative times x plus 1 squared minus 3. Okay, again, I like to just write the standard form underneath it. I think it's easy to see like that. Okay, so let's write out what we have. Our vertex is h comma k. H here is minus 1. Okay, notice that again, h minus, x minus h. We have x plus 1. Okay, so to make that minus, we would need a minus 1. And then k is minus 3. So this, I'm sorry, this should be plus 3 here. Plus k. Sorry, I messed that up completely. Okay, so that's the standard form. So k would be minus 3. Okay, and then a is the number out front, which you guys can see is minus 1. So this is going to open down. Okay, let's go ahead and find another point. So I'm just going to write another point. This again just shows you how steep your parabola is going to be. And again, it's symmetric on both sides, so you just need one point. I'm again just going to use 0. I think that's easiest. So minus 0 plus 1 squared minus 3. So that is minus 1 squared minus 3. So 1 squared is 1, and then you have a minus. So minus 1 minus 3. So minus 4. This would be 0, negative 4. So we can graph those 2 points. Okay, so our vertex is negative 1, negative 3. Here's our vertex. We also know it opens down because a was negative. Then we also have the point 0, negative 4 here. Okay, so make it look like a parabola, so something like that, and then it needs to be symmetric on both sides. Okay, so there's our next graph. Okay, so again, we've graphed this quadratic function, and we haven't pulled out our calculator, and we have not used an XY chart. Okay, next example, we're going to be working backwards. It says find the quadratic function f whose graph is shown below. Okay, so we need to graph this first. So this is the graph that we're going to be finding the function. Okay, here we had the function and we graphed it. Now we're going to have a graph. We're going to find the function. So we're going to be working backwards here. Okay, so over 2, and then we need to go at least up 5. 1, 2, 3, 4, 5. Okay, so 2, 3, which I'm going to write 2, 3 here is the vertex. 1, 2, 3, 4, 0, 5 is just another point. Okay, so we just have to have that information to find our graph. Okay, so our vertex is 2, 3, which is HK. Alright, so let's go ahead and plug that into standard form. So standard form is A times x minus h squared plus k. Okay, so we have f of x equals, we don't know what a is, the x minus h, which is 2. Okay, this is the x value of the vertex, squared plus 3. Okay, now we need to solve for a, which we're going to use our other point here. So I'm going to use 0, 5 to plug in. So 5 is our output when x is 0. Okay, so that is this. Okay, so solving for a, that is -2 squared, which is 4, plus 3. Okay, this is just a linear equation. We know how to solve. So subtract 3, that would be 2 equals 4a. Divide by 4, a is 1/2. Okay, make sure it makes sense. A is positive, so it's opening up. So I'm just going to plug everything in here. So f of x equals a, which is 1/2, times x minus h squared plus k. So there's our, I have numbers for those. Keep messing this part up. X minus 2 for h, 3 for k. Okay, so when solving or moving backwards, we need to find a, we need to find h, we need to find k. Okay, so that's using standard form. There might be a couple on your SAT where it's given to you in standard form, and again, this is pretty simple to graph. It's pretty simple to pick out your vertex. Okay, but a lot of times, which I would say this is going to be most of the time on the exam, it's not expressed in standard form. Okay, so bottom of page 7, I just review again. If f is expressed in standard form, the vertex is hk. If a is greater than 0, the minimum value is f of h equals k. If a is less than 0, the maximum value is hk. Okay, so if a is greater than 0, it opens up, you have a minimum. That's your minimum. If it's greater than 0, it is opening down and you have a maximum. Okay, so you have a minimum or a maximum point always with quadratic equations or functions. Okay, so page 8, we're going to look at how we're sketching these graphs if we're not given standard form, which is almost always the case. Okay, so it says we need to find the maximum or minimum, or this is the vertex, so I'm just going to put above. Maximum or minimum is the vertex of a quadratic function to sketch the graph of the function. Okay, so we have a formula for this, which I suggest memorizing. It says if a is greater than 0, the minimum value is f of negative b over 2a. Okay, that means this negative b over 2a is the x value. Then when you plug that in, you'll get f of x. Okay, so what you're going to do is you're going to have x value of the vertex is negative b over 2a, and then you're going to plug it in to get out the y value. Okay, if a is less than 0, the maximum is still the same. Okay, so we really don't need to pick out minimum or maximum until later. Okay, same formula, negative b over 2a for x, and then plug that in. Okay, so it says find the maximum or minimum of each quadratic function. Sketch the graph without using your graphing calculator. Okay, we're also not going to be using an XY chart. Alright, so we have f of x equals x squared plus 6x plus 2. This is expressed in general form. Okay, if it was expressed in standard form, we can immediately pick out the vertex and graph it. But it's general form. Okay, so we have a is 1. Okay, that's the number in front of the x squared. B is 6. C is 2. Okay, so our formula for the minimum says x is negative b over 2a. Okay, so x is going to be negative b over 2a. Okay, so negative b would be negative 6 over 2 times a, which is 1. Okay, so that is negative 3. Okay, now we plug in negative 3 to find our y value. Okay, so f of negative 3, I'm just following this here. Negative 3 squared plus 6 times negative 3 plus 2. Okay, so that's positive 9 minus 18 plus 2. So minus 9 plus 2, negative 7. So 9 minus 18 plus 2, yeah, so negative 7. Okay, so here's our vertex. Okay, so our vertex is going to be, which I'm going to put arrows here just so when you look back you'll see where they came from. Vertex is -3, -7. Okay, so this is the x value. This is the y value once you plug that in. Okay, so let's go ahead and start sketching this. So we have -3, 1, 2, 3, -7, which I only drew 7 here. There's our vertex. Okay, we can look here. A is 1, so it's positive, so it's going to open up. We just need to know another point. Okay, so we know it's going to open up. And we just need another point, which again, I'm going to use 0 here. I'm going to do f of 0. So this is actually really easy in standard form. F of 0, that's 0, that's 0. That would be 2, which I'll write out. 0 squared plus 6 times 0 plus 2 is 2. So we have the point 0, 2 here. Okay, then when we graph, go through that point a little better, we have a pretty steep parabola here. Okay, so that's how you'll graph in general form. Okay, let's do one more. It says f of x equals -2x squared plus 8x minus 5. Okay, so again, we're given general form, so let's go ahead and write our a, b, and c. Okay, and then we want to find the maximum or the vertex or minimum, whichever we have. So the x value of the vertex is -b over 2a. Okay, -b is -8 over 2 times a, which is -2. So that's -8 over -4. So positive 2. Then we need to plug this in. So f of 2. So this would be -2 times 2 squared plus 8 times -2 minus 5. Okay. So this would be 4 times -2 is -8 minus 16. Oh, I'm sorry. This is positive 2. I got messed up because of this -2. We're plugging in 2 here. So this would be plus 16 minus 5 equals, that's positive 8 minus 5 is 3. Okay, so our vertex or maximum minimum is 2, 3. Okay, so let's go ahead and start graphing this. So over 2, up 3, and then we need to find another point. Okay, again, I'm going to plug in 0. Okay, so that goes away, we're left with -5. So it would be 0, -5. Okay, so we have open, down. Okay, which I should have went over this in the last one. We have,
and then for this one we had a minimum point.
Okay, just because on the SAT it probably won't say vertex, it'll say minimum or maximum. Just remember your vertex is the minimum or maximum in a quadratic function, which our next example I think says just that. Okay, so the next example will be very similar to something you would see on the test. Okay, it says a farmer has 2,400 feet of fencing with which he wants to fence off a rectangular field that borders a straight river. He does not need a fence along the river. The function that models the area of the field in terms of the width is a of w equals 2,400 minus 2w times w. Find the largest area he can fence and find the dimensions of that area. Okay, so let's go over this problem first. We don't really need to know how he got to that function, okay, but we need to know what's going on here. Okay, so he has a rectangular field. Okay, he doesn't need to fence here. Okay, so he has 2,400 feet of fencing. So he needs this plus this plus this to add up to 2,400. Okay, but he wants to find the maximum area. Okay, so his area function looks like this, which he found. Okay, so a of w equals 2,400 minus 2w times w. Okay, so what we're going to do is we're going to
Okay, to maximize the
area, we're just going to find the vertex. Okay, so first of all, let's go ahead and distribute this out so we have it in A, B, and C form. So I'm going to multiply each by W. So 2400 W minus 2W squared. Okay, so A is the number in front of the variable squared, so negative 2. B is 2400, C is 0. So to maximize, we need the x value, which in this case is W. That's negative B over 2A. Okay, so negative 2400 over 2 times negative 2. So negative 2400 over negative 4. That is positive 600. Okay, and then we need to do A of 600, which is 2400 times 600 minus 2 times 600 squared, which you'll need a calculator for this one, which I got 720,000. Okay, so if we were to graph this, you're going to get some picture that looks like this. This maximum point would be 720,000. Okay, that's our vertex. How do I know the graph looks like this? I just quickly, when W is 0, the area is 0. Okay, which makes sense. If you have a width of 0, you're not going to have an area. Okay, so for this one, the maximum area is 720,000 when W is 600. Okay, so the farmer would want this to be 600, this to be 600, and then that would force this to be 1,200. Right, 600, but yeah, 1,200. Okay, so when he builds this fence, he wants to do 600 by 1,200 rectangular field. I'm going to go ahead and write max area is 720,000. This was in feet squared when the width is 600 feet. So there's our solution. Okay, this is very similar to something you might see on the SAT. Okay. Bottom of page 9, we have quadratic regression. Again, if you don't have a graphing calculator, go ahead and stop the video. We're not going to do anything after quadratic. If you do have a graphing calculator, let's go ahead and quickly go through this. Quadratic regression is almost exactly like linear and exponential regression, so we're really just learning a different button, that's it. Okay, so it says when given a data set, first make a scatter plot of your points. So always do that. If it looks like a quadratic curve, do a quadratic regression for the data, making sure to write down. Again, you don't need to know this correlation coefficient. I need to take that out of the text. Okay, example. Would a quadratic function be a good estimate for this data? If so, what function would be the best fit? Okay, so go ahead and turn the calculator on. Stat, edit. We're going to put all of our points in the list, so make sure you clear out the list, which, oops, we have gone over this a couple times. If you don't remember how to do the scatter plot, go back to the very first lesson. I think it's the Heart of Algebra Part 1. Okay, go over that again. There's also other videos on YouTube that are helpful that you can look over this too. I'm just checking my points here. 2, 3, 5, 7, 8, 10, 12, 50, 68, 80, 81, 71, 67, 59. Okay, turn our stat plot on. Oops, I don't think I turned it on. I didn't. Okay, change the window. X minimum is 2. I'm going to use 0. Use 0 unless you have negative. Maximum is 12. I'm going to go to 15 just to go out a little bit more. Y minimum is 0 unless it's negative. The max is 81. Again, I'm going to go to 85 just in case. Go to Y equals, clear out all of your graphs just so you don't have lines in there. And graph this. Okay, just we want to see if a quadratic would work. Yes, it looks like we would want to use quadratic. So far, all we've learned is linear, exponential, which if we did linear, I'd probably go decreasing, but what's happening here, we have an increase. Okay, same with exponential, I'd probably use decreasing, but it's leaving out this increase here. So quadratic would be good. You can kind of see a parabola through this. Okay, so to find quadratic regression, we go to stat, over to calculate, look for quadratic regression, which is number 5 on my calculator.
Okay, if you have an older version, you'll need to type in L1 and L2. Okay, calculate through here, and there we go, which is ax squared plus bx plus c. So we have a is approximately negative 0.92, b is approximately 12.86, and c is approximately 33.41. Okay, so our function that best fits this data is 0.92x squared plus 12.86x plus 33.41. Okay, so there's our best fit for that data. Let's go ahead and graph that and check, make sure it looks good. Okay, so go to y equals, and we're just graphing this. That was a negative, right? Negative 0.92x squared plus 12.86x plus 33.41. And graph. Which you can see, it looks pretty good. Okay, so we're going to stop there. We will start on page 10 for part 3, and this is solving quadratic equations.